Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later for my college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He's not only focusing on theory part, he's doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exams to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone, which is really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother. I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary. That is, the students' doubts gets cleared and everything else. So today I came down to the XLR office to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens, and they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that I had a very good experience with XLR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about XLR program. I took part in the XLR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you XLR for giving me this opportunity, and I would also recommend all my friends to take part in the XLR programs. Thank you.
Hello everyone, hope I'm audible and the screen sharing is also working. Can you confirm that with a quick yes in the chat box? Audible and the screen sharing is working. Yeah, hi Dinesh, hi Pawan, hi Rutuja, hello Aditya, Tejaswini, Srija, how are you? Good evening, good evening. Yes, so yeah, very few members today, only 100. Fine, we'll get started anyway. So see here today, our topic is stacks. Last talked about on Friday, we have talked about linked list. We have gone through different model questions for it: slow pointer, fast pointer, previous pointer, current pointer. Okay, we have seen all of it. I hope you enjoyed that session. You have got good idea about it. Linked list is a very small topic. Okay, if you want to take one particular topic in your DSA journey, linked list would be one of those first. Okay, there are two peoples. Like first way of thinking is linked list is very difficult and all, but once you start visualizing it, once you start writing it on a piece of paper, so it will become very easy actually. Okay, so take my word, try to visualize linked list. It is gonna be very easy for you. Try to write it on a piece of paper and do all those operations with your hand. There are only 20 or 25 questions. That's it, 25, not more than 25. Okay. Right. So just a second. Let me grab my files about where I have stacks here. Yeah. Yes, so see, coming to stacks, okay, we have seen linked list. We are going through one more data structure in linear, that is stack. Now, stack is a linear data structure. It uses the principle last in, first out. You might have seen some applications. We have talked about it very much in our first session. We have gone through each and every, okay, linear, non-linear data structure. I gave you some examples. The best example is undo it, redo. The last change that you made will be the first one to be removed also. Okay. So stack is a linear data structure. It's a restricted data structure, you can say, where you will be able to insert and delete elements only from one side. Okay. You take an array, you can access the array from the beginning, from the ending, from the middle, anywhere you like. Okay. That's how an array works. Now you come up with a stack, just rotate the array with 90 degrees by 90 degrees. Okay. Now simply you will be only able to access it through one end, the top end. Okay. From there only you can insert any data. From there only you can delete any data. That's it. That's what we call as stack. Done. Now it uses last in, first out, LIFO, or first in, last out, you can say. The last inserted element will be the first one to be removed. And you already know about the terminology. Okay. If you are inserting any value into the stack, we call it push. If you are deleting any value from the stack, we call it pop. And if you want to check, okay, what's present at the topmost value, we call it peak. The operations are pretty simple. Okay, we'll go through them. We'll implement stack first, then we will move forward. Now, coming to applications, you see, we use stack everywhere. Okay, individually, stack has good questions in it, but when we are going through non-linear, okay, when we level up in algorithms, we'll be using it a lot. It's a very useful data structure. Okay, if you want me to rate linked list, stacks, and queue, I would rate stacks higher. Okay, you see, because recursion is one of the applications of stack data structure. Recursion is one of the applications of stack data structure. So I would rate stack very highly. We will be using stack a lot moving forward in algorithms and all. Even I'll show you some questions as well. Okay, you can follow them and that will be good. Done. Now, coming to all these things and all. You see, we are using Python, so we don't have any cap on, okay, overflow condition, underflow condition. Underflow condition will be there everywhere, but whenever the stack is filled, okay, let's say we have a glass of water which is completely filled to the top. If you try to pour even more water, okay, it cannot hold it. That's what we call as overflow state. Same thing here as well. Okay, if the stack is completely filled and you try to insert one more element, that's what we call overflow condition. That's what we call overflow condition. Okay, done. Now, second way, when the stack will be empty, if you don't even have any element inside your stack. Okay, if top value that you are accessing, if it is not pointing to 0, then that's what we call underflow condition actually. Okay, sorry if I spelled it wrong. Now insertion, if you are inserting any value into this, that's what we call as push. Now deletion, if you are deleting any value from the stack, that's what we call as pop. You will also get the item with you. And basically, okay, so whatever values you have, top will be pointing to that. Okay, so top will be pointing to whatever value that you have, whatever the index that you have on top. So that's how we insert, delete, or keep a track of everything. That's some basics about it. That's some basics about stack that you have seen. Okay, now let's talk about let's talk about this one, problem solving using stack. Okay, I'll be picking some specific questions from these. Okay, as you know, mastering data structures and algorithms will take some time. We cannot simply go through everything in 2-3 hours or so. I'm giving you a very good idea. We are going through, okay, what's all there, kind of like this is your roadmap we are showing, boot camp, you can understand, right? So first, you need to understand how things work in stack, okay, theoretically. Academically, you might have seen how to implement a stack, how to perform operations on it. Right? And then looking at the bigger picture, recursion is an implementation of stack. Backtracking is an optimized version of recursion. We have something called monotonic stack and all. So, and there are standard questions like balancing parenthesis, okay, expression evaluation, postfix, prefix, okay, notations and all. We'll get to that part. We'll slowly see that, right? Now, see, we have three operations: push, pop, peek, okay, and by using these three operations, and we will be able to solve a lot of good stack related questions. Okay, this is going to be very good brainstorming sessions for you, right? These are some easy level questions. I'm showing 5 per slide. We have the most popular question in it, balancing parenthesis, and we will be implementing stack, okay, by using queues. We'll be implementing queue by using stacks as well moving forward in the future. These design questions are also asked in a lot of ways. Okay, normal questions and all design questions. They would ask you to design something. So these are there. So we'll talk about it. There is something called min stack. We have a baseball game question, and these are the other questions. You see, total 10 questions. 10 questions. These are easy questions from stack. Okay. Now, these are some level questions. You see, 5 questions and 5. Okay, total 10. We'll be picking one question each module. You can say maybe we'll go a bit easy first, then we will start with a bit medium. And we also have some hard level questions, which it's better for you to explore some algorithms first, then come back to them. Okay, hard level are not that easy. It will take you very good amount of time. If you have remembered any of our previous sessions, for one question, which is like kind of like easy 60% acceptance rate also, in order to discuss all 3-4 possibilities, it took us 1 hour. Okay, that's how long these things generally take. You have some 500 questions or so. If you do them, or 150 questions properly, you will get a product-based company. Not that such a big deal, but that 150 questions you have to do in such a way that they will help you to solve, okay, 10x, 1,000 questions more. That's how it should be. That, right? So these are some hard-level questions. Don't worry. We are in the last week. On last day, I'll be giving you all the roadmap, etc. What else you can do. Okay. So don't worry, you can explore all those resources. So fine, just showing you. Stack is very important for us. Okay. So these are some common stack problems we have. First, we will go with the classic stack problem, that is stack operations. We'll go through push, we'll go through pop, we'll go through peek. Okay. We'll be going through parenthesis matching, etc. and all. Then we have monotonic stack, as I told you. Okay, well, I'll give you a good intro about it. Okay, generally it takes a good amount of time, but I'll give you a good intro about it, so don't worry. Again, stack is used for backtracking. There are some examples. I'll show you the questions as well. Expression evaluation is there. We will be doing that today as well. And stack for interval matching is there. We have car fleet, skyline problem, rectangle merging. These are some things. So these are 5 models that we have. Let's try to touch all 5 models. Okay. We'll go through the classic stack problem and expression evaluation first. Then we will explore monotonic stack, and stack for backtracking is anyway there. And interval merging. Okay. Tomorrow. First, we'll go through level 1 today, then level 2 tomorrow. And don't worry, all these questions, etc., whatever I'm telling you as a roadmap, I'll deliver all of this to you in the last day. Done? Now let's first simply implement a stack. Maybe I'll just code it in my VS Code. We can also have geeks for geeks, etc. and all. So not required as of now. Let's code it here. So today is day 11, I guess. Day 11.py. Okay. We have been coding everything in lead code only recently. Now, as I said, talking about stack. Okay. Stack is last in, first out data structure. First out data structure. Will not waste much time in the theory part. Last in, first out, okay, data structure, or you can also call it as first in, last out as well. Okay. We'll do one thing. We can implement stack by using linker list. We can implement stack by using okay, normal arrays as well. We'll go with an array because we will be using an array only. Okay, well, let's directly jump into stack related questions. Okay, all this is pretty good for academic stuff. We can happily have a very good discussion. But since on the first day itself, I have shown you how a stack looks like, what operations will be performed in an animated way, and we have discussed good examples as well. So not needed. We are here for product based companies. So let's quickly jump into it. So see, we have two ways of implementation. First, we have arrays. Second, we have a linked list. Okay. I'll go with an array. As I said, stack is a restricted data structure. So first I'll take an empty stack. This is how I'm taking it. Done. In order to perform push operation, okay, push operation means I have to insert an element. We have the method dot append. So what will append do? Append will add an element at the end of the array. Okay, so imagine I have my stack here in this manner. Okay, let me connect my graphic tab once, then we are good to go. There's the cable, yeah. You see, what I'll be doing is, we are not going to create anything fancy. Python already provides us the inbuilt methods to use it as a stack. So let's continue with that. So this is my array. Okay. Let's imagine I have some elements here. Fine. Right. This is my array. I'm gonna name it as a stack. Now I'm just rotating this array. That's all I'm doing. Okay. And I'm keeping one end open just to show you that I want to insert from this end. Okay. I know it's not perfect, but it will do the task for us. So 0, 1, 2, 3, 4, 5, so on. It can be of any length. 0, 1, 2, 3, 4. Okay. So I think, yeah, one more value is saying 5. Okay, right. So just rotate the array by 90 degrees. Okay. And if you're only inserting from one end and deleting from the same end, that's what we call as a stack. So this is our stack. Initially, if you observe, I do not have any values inside my stack, so I don't have anything to point to. There is no top to it. So initially, top will be equal to -1. Okay. And whenever you use dot append, this is nothing but push. Okay. So what will happen if I push 10? I have 10 here. Let's say I have appended 10. So first value in the array or first value in the stack is 10. I appended 20. I appended 30. I pushed 40, pushed 50, pushed 60. Now Python is dynamic, so you don't even have to worry about the size of the stack. Okay, so you can make it as big as you want. So it will never overflow, you can imagine. Python is dynamic, so it will always allocate the memory. Now if I want to pop anything, okay, so push means adding at the end, okay, last in, first out, we are adding an element into our stack. Now pop, we have a method called pop in arrays, which is going to give us the last element, okay, last inserted element will be given. That's it. So we will use append to insert an element at the end of our stack or array. We will use pop method to remove the last value. And whenever you want to check out what's present at the last place, we can happily use -1. Okay, so we will be able to get that. But since we want to make it look like a stack, so I'm going to take top equal to -1. Whenever I insert an element, I'll increment the top value. You see, first element, top -1 plus 1, top will point to 0. Second element, top will point to 1. Third element, 2. Fourth element, 3. Fifth element, 4. Sixth element, 5. If I delete, I'll decrement the top. Okay, that's how the concept is. Pretty easy, pretty basic, pretty simple. Let's go ahead. Let's get started with it. So I have an empty stack. I already have an empty stack now. So first, we can make it as a menu based loop. Okay, sorry, menu driven program we call it. Okay, we can create an infinite loop. Let me write while, right? True. This is an infinite loop. This will keep on executing. We can present the user some options. The options are, first one, enter 1 to push. Okay, second one, enter 2 to pop. Done. Third one, enter 3 to display. Okay. Fourth one, enter 4 to peak, means what's present at the topmost place. Now, fifth one, enter 5 to exit the program. Okay. So 1 for push, 2 for pop, 3 for displaying, 4 for peak, and 5 to exit. These are my menu options. So I need to take a choice from the user, choice equal to int of input. The user is going to enter the choice, or we can maybe happily keep this here. Why keep another print statement there? Yes, I'm keeping a print statement here. That's it, done. Now, what else we have to do? Just we got the input. Okay, choice it is ch, not character. If choice is equal to 1, if choice is 1, push. So in order to push, I should have an element with me. So let's take an element. Okay, element equal to int of input. We'll ask the user to enter element to push. Okay, so the user will enter an element to push. We need to push this element into the stack. So how can we push that? So stack dot append. Append is the method we have. It will insert an element at the last, at the ending. Okay, that's choice 1. Now coming to choice 2. Copy this. LF, if choice equal to 2 means pop. Okay, pop will not be taking any value, so we can simply pop it and display it. So let's do that. So print, okay, popped I'll write, comma, stack dot pop is the method. Automatically, if you're not providing an index, it is going to remove the last element. That's good. Now again, LF choice equal to 3. What do they want us to do? They want us to display it. And from where do we have to display? From the last value. Okay, from the last value. We can go with -1 indexing and all, negative indexing you guys have seen. But let's use top here. Okay, you see I have not defined top anywhere. Let's take top. You see top is equal to -1. Let me take it in lowercase only. Initially top equal to -1. Whenever I append a element, top plus equal to 1, top will be incremented. Whenever I delete any element, top minus equal to 1, top will be decremented. Okay, now choice 3, we need to display. So imagine the values are in this manner. Let's say I have 3 values. Whenever you're feeling anything a bit difficult, try to imagine it. Okay, try to imagine it. You see here, let's say I have the elements in this manner, 10, 20, 30. Okay, I don't have anything here. You can just reverse it. This is what we are imagining as a stack. 0, 1, 2. Okay, so top is currently at second index. Second index. So what do I have to do? I need to start from top. I need to start from second index. I need to access first index. I need to access 0th index. This is how I need to print. Okay, then I'll get 30. After that, in the next line, I'll get 20. After that, in the next line, I have to get 10. This is how I need to pop everything. Okay, so since I have taken top here, let me start with top. So for index in range of, okay, in range of top to, I have to go up to 0. So -1, because -1 is exclusive. It will go up to 0 only. Done. Now what is the step value? Step value is -1 as well, right? That's it. So now we are starting from the top, we are going all the way down to 0, right? So I'll just print the element, print stack of index. Okay, I'll be getting each and everything. I'll be getting each and everything in a separate line. So let's go with print stack elements are. Okay, just making it a bit fancy. Now talking about for peak. Peak means just knowing what's the topmost element. So LF choice equal to 4. We need to print the topmost value. Okay, top element is equal to stack of top. That's it. Top element is done. Now LF choice is equal to 5. Choice equal to 5. We need to exit. Okay, so print. Okay, or program ended. We all know whenever we have a loop, the loop will exit in only two situations. One, if this condition is false, but this condition will never be false. It's forever true. Second, whenever it executes break keyword. Done. That's it. So if I run this now, we'll have couple of issues. Let's talk about them. You see, it looks very nice, very nice. Now see here, coming to first one, if I write it push, it's asking me to enter an element. I'll enter 20. That's good. I'll go with push again. I'll enter 30. That's good. Let's go with display. 30, 20 we are getting. Last in first out. Last inserted element is the first one being short. Now we have some issue. What's the issue here? You see here, when we are going with it, okay, the choice we are taking is in the same line, and also it's not that good as well. So let's try to write a slash n here, okay, and maybe everything else is fine. So let's check it out first. Done. So first value 10. Sorry, yeah, this is another issue I wanted to show. Anyway, you see here, if I go with push 10. If I go with push 20, if I go with push 30, now I want to display it 3, 30, 20, 10 we have. And if I want to go with pop, okay, you see pop with 30 is working. If I want to go with peak, yes, we are getting it. Now the problem is, if you observe, if I keep on popping it, okay, if I write 2, if I write 2, if I write 2, I'm getting an error, okay. Why you got an error? Because we need to check if there is an element before popping. If we have an element, then only we can pop. Na? From empty stack, we cannot pop any element. That's the error we are getting. And one more thing, you see here, I have 5 options. If I enter 9, then it's not doing anything. Okay, it should give me some sort of error message, right? You see 45, no, nothing is happening. So we need to limit the user to enter options from 1 to 5. Maybe if the user is entering anything else, I do not have any default case now. If the user doesn't enter anything from 1 to 5, then we will display a small default case to him. Okay. And we also need to check whenever there is pop involved. Okay. We will also check if it is empty. If it's empty, then only we can pop. Otherwise, we cannot. Okay. Now, how we can check it? Because top is keeping a track of everything. If nothing is there, top will be -1. Done. And you can also create a function called isEmpty as well. You can check if it is empty or not. So not required. So let's go ahead. You see, before popping, if top is not equal to -1, then only I can pop. If top is equal to -1, I cannot pop. So what do I have to do? I'll go with else. I'll print stack is empty. Stack is empty. Done. Now we are printing stack elements, that is fine. Program ended, that is fine. Top element, yeah, again, when you're trying to access top element, if you have any element, then only you will get, na? Okay, so again, same thing. We need to check if else here. Let me copy this if. We'll paste it here. If top is not equal to -1, then we'll print it. Otherwise, stack is empty. Okay. Then same thing for display also you can do, but not needed. Now, if the user enters any other option apart from these 5 options, what else we can do is I can have a default case. Maybe the user can enter 9, 10, 15, 20, anything it can be. So anything which is not in 1 to 5, then I'll print a default case. What is that? Okay. Choose or enter, okay, between 1 to 5, anything, okay, or invalid input we will say. Let's do that. That would be more good. Okay, invalid input. Done. That's it. So let's check it out. Let's run this one now. Right? What is that we are getting? Maybe a small glitch. Run it again. Yeah, now it's fine. Why we got it, I don't know. But anyway, you see 1 to push. Pushing element is 10. Let's enter it that way. 1 to push, 21, 30, 1, 40, 150, 160. Done. If I go with display, I should get everything starting from 60. You see? Sorry, what have, oh, sorry. I went with peak actually. Now go with display. There's a 60, 50, 40, 30, 20, 10 we are getting. We don't have that lines to indicate the boundaries, but anyway, it is a stack. Okay. So display is working, peak is working. Now let's go with pop. So pop would 60, pop would 50, 40, 30, 20. Now 10 also pop. Do I have any other element to pop? If I go with pop again, it is saying stack is empty. Okay, you cannot pop, right? So let's try to go with peak. Stack is empty, you cannot peak. Very good. If I go with display, stack elements are empty. You can also write empty there. Now if I want to get out of the stack, I'll go with exit. Okay, 5 exit, program ended. That's it. This is stack implementation by using an array. This is stack implementation by using an array. Okay, we're using an array to implement push, pop, peak, etc. and all. Right? So understood this one. This is pretty easy. I hope you understood this one. Stack implementation. Any doubt till this point? Any doubt till this point? Any doubt till this point? Done? Right. If you want to check whether the stack is full or not, maybe you can, while you are starting, you can take the size of the stack. Okay. If I can also write it, let's do that. So size is equal to int of input. We'll ask the user to enter the size of the stack. Enter size of stack. Okay. Enter size of stack. User will enter the size of the stack. Whenever you want to push, you just need to make sure if top is equal to size minus 1, because size is a number and top is an index. So if top is equal to size is not equal to size minus 1, or less than size minus 1, or less than size will be fine, then this can be performed. Otherwise, you can print overflow condition. Okay, overflow state. So if you are entering your stack as 5 elements, and if I perform push, you see 10, perform push, 20, perform push, 30, perform push, 40, perform push, 50. If I want to push again, I think okay, yeah, fine. Let's go 6. Yeah, you see, maybe indexes I have given one more value. This is size minus 1 only. So you see, we are getting overflow state. If I try to push again, overflow. If I pop something, then I can push. Okay, so that's how it will be. You can add overflow. You see, we are printing stack is empty now. That's nothing but underflow state, etc. and all, right? That's all we are doing. We are using top to keep a track of how many elements we have. We can also go with length. Okay, not a big deal, but you will understand the general terminology. We have length functions, etc. and all here, but in C programming, we will be going with this one only. That's a common indication, right? Done. There is nothing to be confused in this while loop. This is a night loop actually. So until and unless this condition becomes false, it will keep on executing the while loop statements. Okay, so whenever the last statement of a loop is executed, it will again come back and check the condition. So until and unless that condition is false, so it will keep on executing it. So while is a condition based loop. Okay, in Python, while and for are a bit different. For is a iteration based loop, while is a condition based loop. So until this condition fails, while will keep on executing it. For will only do it for a fixed number of iterations. Okay, so what's present in 31st line? 31st line, we are accessing everything from backwards, from the last index to the 0th index. Okay, so generate the range. You will be able to understand it. So what's the top value if I have 5 or 6 elements? Let's say if I have 5 elements, the top value is going to be 4. Okay. This is step -1 from it. So top value will become 3. -1 from it, top value will become 2. -1 from it, top value will become 1. -1 from it, top value will become 0. And this is -1, this is the ending. So we need to end one value before it. So you'll be getting starting from top to 0. From last to first, we are accessing all the values. Okay. We are printing. Stack means from last only we'll be able to access. Now. That's what we are doing. Okay. In Python, you can have as many. Python is dynamic, so you can have as many values as you want. Okay. Python doesn't have a memory restriction for it. You can take as many as you like. And in other languages, you can also make them dynamic. C programming has dynamic memory allocation in it, so you can make it as big as you want. So for this, as much as you want. So size is on you. So you can take as big as you want, right? That's it. So this is a little intro about how to create a stack by using arrays. Now let's talk about linked list. Okay. How to implement stack by using linked list. As I'm saying, stack is a restricted data structure. Okay. You take an array, you restrict yourself, okay, by only accessing the array from the ending for insertion and deletion. That's what we call stack. Now you take a linked list. I'll roughly stack here. Okay. Let's say initially my linked list is not pointing to anything. I don't have anything, so none. Okay. Head is pointing to none. My stack is also not having any element. Top is equal to -1. I've inserted one value. Okay. That's 10. I have inserted one value, that is 10 in my stack. I have to insert one more value. If I insert it here, okay, you see I'm inserting it here. This is an issue. Why? Because stack is last in, first out. The last inserted element should be the first element that you have to access again. And in linked list, the first element that we always access is head. So if you want to make a linked list work like a stack, what you have to do is you have to insert at the beginning. Okay. You see here, you have to insert at the beginning. So if I'm taking 10, you see 10 I have and I have. If I'm inserting one more value, pushing one more value, 20, you see 20. If I'm pushing one more value, 30. If I'm pushing one more value, 40. Okay. If I'm pushing one more value, 50, etc. and all. So pop, last in, first out, last inserted element is 40, will be the first one to be deleted. Okay. Last inserted element is 30, will be the first one to be deleted. Or first inserted element will be the last one, last out, or last in, first out. Okay. So in order to make a linked list work like a stack, you need to perform two operations. First one is push, that is insert at beginning, will replicate push. Now what about pop? Same thing. Delete at beginning, delete at beginning. Okay. Restricted data structure. We are only inserting and deleting from one end. That's it. So I hope you all have seen insert at beginning and delete at beginning in linked list. This would be fairly easy for you. That's one more way of implementing stack. There are two ways, arrays and linked list. Okay. Arrays in the sense here it is list in Python, not arrays. That's the basic of it. That's the basic of it. Let's get started with some stack related questions. So let's go with leak code. We'll start with the most basic question, that is in parenthesis, or let's see if there is a simple for you. You see, designing is also one of the OA questions people generally touch. Okay, you can click on it, you will be able to explore. So simply whatever we did is designing of stack, designing of linked list only earlier. So let's see stack, 178 questions we have. And you will also see monotonic stack somewhere around here, 50 questions or so, I don't remember. Yeah, 72 questions. These two are important. Now, see, coming to stack, let's sort it through difficulty or acceptance rate. We have binary trees and all. We'll explore them a bit later. Yeah, we'll start with the first one only, valid parenthesis. Okay. Now, these are the classic stack patterns. Now, what happens in this valid parenthesis is, I'll give you a good amount of time, go through it, go through the question. Valid parenthesis, see what is meant by a valid parenthesis. Okay, we have a lot of examples here. Check it out, what's a valid parenthesis? They are giving you a string. You have to check if it is having valid parenthesis. Now, what is that? How it's valid? It only contains brackets, parenthesis, curly brackets, square brackets. You need to determine if the string is valid. Now, what is a valid string? Opening brackets must be closed with the same type of brackets. Opening brackets must be closed in the correct order. Every closed bracket has a corresponding opening bracket of the same type. Now, what's that? Okay. Let's try to make some sense out of it through these questions, to these sample. I want you to go through it, and I also want you to understand these 3 points again. So maybe I'll copy the text, I'll keep it on the right side so that you can have access for it. Done. So see all these 5 sample test cases, figure out something, try to come. The chat is open for everyone. What do you think we can do? How to use stack? Since you already know we are using stack data structure here, this is an example question related to it. You already know the solution steps, like what we have to get started with. We have to use stack. We have simple operations in it. You have the question in front of you. Try to figure out some way. I want to see how you are thinking. Okay, how to use stack here in order to get it. I'll be giving you 3 minutes. I want some sort of answer in the chat box. Okay. How can we use stack in order to solve it? Okay. How can we use stack? Any algorithms, any step-by-step way. So you have 2 minutes, 40 seconds more. Okay. Do post something in the chat box. Okay. I want you to think. It's okay. I'll be able to happily, but if I have to make you think, this is the only way. I need to ask you a question. You need to come up with an answer. Even 10% is good. Okay. When there is a situation when I'm not available, that 10% will slowly move towards 100. That's what, right? So yeah, 2 more minutes, post some answers. How can we use stack? What can we do? How can we get started? You already know the question. You understood it. You know which data structure to use. You know the operations of it. Try to make some sense out of it. Yeah, small error there. Yeah, fine. Done. We are getting good responses, right? Okay, okay. Very good. Chakravar. We can strip the string and then push it, strip the brackets into the stack, and then one by one checking corresponding brackets, or we can use a dictionary. And that's a bad idea. One more thing, we don't have to strip because they have clearly given it will only contain brackets only. That's it. Okay, so we don't even have to do that. That's fine. So push every left bracket and pop when you encounter a right bracket. Very good, very good. Good answers. Yes, guys, that's it. That's how basic it is. Okay, you see, when you learn a topic, or this is the first thing I have told you when we have opened LeetCode, you will go through the problems tab. Okay, now let me click on it there. It's reloading. Maybe I don't have enough internet. It's fine, I guess. Yeah, you see, I told you to come here. These are most asked question topics that you are getting. And arrays and strings will be in the top because hash table we will be using an array. Dynamic programming is nothing but array. Sorting we will be using an array. So we will be seeing these two things on the top. So don't worry about it. Whenever you are learning a topic, let's say last session you have learned linked list. Okay. So where do we have linked list? 72 questions, or so somewhere 82. Where is it? What happened to linked? Yeah, 82 questions. We have 82 questions in linked list. Even if you open it, you will have some overlap between other questions. So you will learn a topic. You will try to solve 20, 25 questions. Maximum 25, 20 will be enough. Good quality questions. It's not about number. Quality over quantity. You learn a topic. You'll go through those questions. It can be an algorithm. It can be a data structure. That's how things should be, right? So we are learning stack. Same thing. We'll open it. We know what operations we have to make. We need to try and solve it in the stack way. Try and solve it in the stack phase. So it's very easy. It's very easy. First, before getting started, it's very important for us to know when it will be right, and it's also very important for us to know when it will not be. Okay, let me make it clear. It might sound a bit confusing, but whenever you are trying to solve a question, obviously you need to know the right ways. Okay, right way of solving it. You also need to know the wrong way, guess the wrong type of inputs and all. Let's try to do that. You see here, we have opening bracket, closing bracket. This is fine. So let me try to zoom in a little bit so that we can see some input out better. Done. Now, why did this go wrong? Okay, what happened here? This one element is opening bracket, the other element is closing bracket, then it should be correct only now. They are clearly mentioned. Opening bracket should have the same corresponding closing bracket. So if I have opening parenthesis, I should be having closing parenthesis, not closing brackets here, like square brackets. Okay. So that's one thing. So what we will be checking is, if I have any opening, as you said, we will be pushing that into the stack. If I get a closing, and if the last opened bracket is not of the same category, means if I have closing as parenthesis, the opening should be parenthesis as well. If I have closing as square, the opening should be square. This is what corresponding means. If I don't have it in that way, then that's red. Okay, so it's not correct. One more thing. If anything gets started with something like this, okay, you see, let's say I have something like this. Done. I have accessed it. Do I have any other opening brackets? No. Opening brackets have to be closed in the same order. Okay. Opening brackets must be closed in the same order. Opening brackets must be closed the same type of closing brackets. And every closing bracket will have a corresponding opening bracket. Means I'll show you. We'll write the solution. We will be getting an error. There you will see that. So these are some things you need to come up with examples where your code can go wrong. So around that, we will be building our solution. Hidden test cases basically. So it's to get started with a simple question, but once you submitted, hidden test cases will not be visible for us. They will be checked in the background. So when you are submitting any question, you need to make sure you're solving each and everything, right? So valid parenthesis this is. So you have already seen there. Done. Now see here. Let's see the implementation. Let's say I have this string. Is this a valid string? Yes, let's figure it out. I'll be taking an empty stack. Okay. I'll be taking an empty stack. You see like this one. I'll be accessing each and every bracket, each and every character inside my string. So the first character that I'm getting is that opening square bracket. So we are checking if character is in opening square bracket or opening curly bracket or opening parenthesis. Now, why only these three? They have clearly mentioned in the question. I'll only give you these three pair. So why opening, why not closing? I'll tell you in a while. So if I have an opening, I'll be pushing it into the stack. Okay, stack.append of ch. We have seen this implementation just now. So I've pushed it, right? Very good, perfect. Now, if is executed, none of the below will be executed because link, okay, if LF and all. We'll move on to the next iteration. Next iteration means we'll access the second character. Okay, what is the second character? That again, opening curly bracket. So is this a opening square or opening curly or opening parenthesis? Yes, it's a opening bracket. So we will push it into the stack. So see, we are pushing it. Done. Again, next iteration. I got an opening parenthesis. Is this an opening bracket? Yes. Opening means push. Okay. Now, again, next iteration, next opening. If you are getting a bracket, push it into the stack. Now, what about closing? Okay. See, I got closing bracket there, so we cannot push it. What do I have to do? If I pop an element, means if I'm popping any of the, like if I'm popping this stack, which one I'll be getting? I'll be getting a opening bracket. Sorry. Yeah, I'll be getting an opening bracket. I need to check if both of them are corresponding to the same one as well. Okay, I need to check if the curly braces is closing, the opening should also be, the last inserted element into the stack should also be a opening curly bracket. You see, the character that we have is closing curly bracket. Done. So I need to pop an element from the stack. If that popped element is equal to, okay, opening curly bracket, then both are matching, I can proceed further. If it is not matching, this is not a valid parenthesis, I can stop. And one more thing. Sir, why are you performing pop? Because if they are matching, we can remove it. That pattern should not exist anymore. It will affect our future calculations. Whenever you are trying to perform pop, you need to take the length. If you have an element, no, you can pop now. If you don't have one, you cannot pop. You see, we got an error earlier. That's what. So if length is equal to 0 or stack.pop of element, we are getting opening. If it is not equal to this opening, then I'll be returning false. So since none of that worked here, I'll go with the next iteration. Okay. Again, next iteration, I got a closing parenthesis. So if the character is closing parenthesis, which is yes here, I hope you are looking at the animation. And the stack is not 0. Yes, it is not 0. Or if you are popping, if the length is not 0, if you are popping, if that element is not equal to opening. Now I've popped it. The element is not equal to opening. It is equal to opening. So it's matching. I should not return false. I have to continue. I have to check if it will be false for the next one. Now again, let's go through it, speed run it. Okay, there is a small error in animation. Do not worry about it. We are still working on a lot of things. Now if character is opening, we need to push. Okay. If character is opening, the next character is like opening curly bracket, we need to push. Character is opening. Yes, we need to push. Character is closing. Yes. So closing means we need to pop one element. Character is equal to closing square bracket. So if the length is not equal to 0 and if you are popping an element, it should be opening square bracket. And I have popped it, it's opening square, so it's fine. So I will not be executing false. I'll check the next elif and I'll go with the next iteration. Next value I'm accessing. Character is not opening. Is it closing parenthesis? No. Is it closing square? No. Is it closing curly? Yes. If the character is closing curly, if I have element in my stack and if I pop an element, it should not be equal to, okay, opening. If it is equal to opening parenthesis or opening square bracket, then I'll return false. Now it is equal to opening curly only. So I have closing curly and the last element I have popped is opening curly. So both are matching. Again, I need to go with the next one. Okay. Next character. You see, all of them will be matching. So we have closing curly, opening curly, gone. We have closing curly, next iteration. And in the stack, we have opening curly. So that is also good. I have closing square, and in the stack as well, I have a closing square. Now you will come out of the loop once every character is completed. You will check if stack is empty or not. Sir, why do we have to check it? Let me show you the hidden test cases, then you will understand. If stack is empty, then return true, otherwise return false. That's how it will be done. So that's a parenthesis. Now we have Java implementation. Let's see if we have one more example for this, or this will be it. Yeah, you see here this one. Now if I'm taking something like this, you see opening pushed, okay? I'll go through that, right? If I have opening pushed, okay? If I have closing, which closing I have? I have closing square. So it's not opening, I'll not push. It's not closing parenthesis, that's not the condition. It's closing square. So if the length is not equal to 0, means if I have an element to pop, if there is an opening inside the stack, then if I pop it, if it is not equal to opening square, now opening parenthesis is not opening square, then you see one of the conditions is true. Okay, so now elif will be executed for the first time. So what do we have inside elif? We know it's not a valid string. This is how it will be returning it. So it will be returned false, right? That's how it will check it. Now let's see, there is more assumptions for it. Let's come back here. Let's code it out. It's pretty easy once you start working with stack, okay? And as you move into non-linear, it will make you cry a little bit, but that's okay. That's everything is a part of the journey. You will slowly grow. Now let me take a small stack equal to empty, okay? Now, for character in S, for character in string, character is equal to, you can write it in this manner, character equal to opening parenthesis, or character is equal to, okay, opening square, or character is equal to opening curly. Now, why I'm not using membership operator? Because in other languages we'll not have it. So I'm training you to be able to be converted into C, C++, Java with ease. Okay, Python has very simple syntax. So things generally, the world will not work like Python. Otherwise it would have been easy. I think I've used curly brackets here. So let me remove it. Yeah. If character is opening, then I have to append it. I have to push it, stack dot append of ch. That's it, done, append it. If it is not opening, elif, if it is not opening, if character is equal to closing parenthesis, then if I pop any element, pop any element in my stack, it should be opening, so that the opening brackets will be closed in the correct order. And for this closing parenthesis, any opening bracket will not work. It should be closed by opening parenthesis only. Okay, so this is one condition. And if If I pop an element, stack dot pop, okay, it will give me a character. If it is not equal to, opening, then what will I do? I have to return false. You see, they are only going to tell you to return true or false. Now, why did I choose this? You see, the character I got is closing parenthesis. If I pop, it should be opening. If it's not, then it's not valid. So return false. Goes with all the two brackets as well. Okay. So here, let me make it square. Let me make it curly. Square. Let's make it curly. If it's not in this way, then it is false. If it checks for every character and if it comes out of the loop, then I'll be returning true. Okay. This is what you as a beginner will be doing, right? So you need to do this part. Then if you run it, we have a lot of test cases. These might cover some of it here. Or if all 5 are true, you see, in exam, they will give you questions in such a manner. Whatever sample input output they give you, it will be true. Okay, even if you go with partial logic as well. You will think, okay, every test case as true. I'll quickly submit it. If you submit it, you will be failing a lot of test cases. Let me show you that. And this hidden test cases part will not be visible. Whatever public test cases are there, means these which you are running is the only part that's visible to us. So everything will be checked in the backend. So if I submit it, it will fail a lot of test cases. Why? Because there are 2 more things that I wanted you to look at. You have already seen that in the presentation. Now see, it's giving you wrong answer. Okay, how many test cases did it pass? Only 6 out of 1 or 2 passed. Okay, it's very important for you to try to come up with different other scenarios where your code can fail. Now let me show you how my code can fail. Let me write my own custom test case. Let me remove all others so that you can understand what's happening. Then so see, if I start with a opening bracket, okay, if I run it, I'll get an error. I want you to check. Okay, running. Maybe slow internet a bit. Yeah, it's taking a lot of time. I hope everything is audible and visible from my side. Okay, my voice is breaking. Done. Maybe a small internet issue will be corrected. I'll give you a quick review of it again. Don't worry. Now everything is fine. You guys are able to hear me. Everything is fine now. Audible? I'm audible or it's still breaking? Is it still breaking? Hello. Okay. Yeah, see here. You see, test result failed. So what's happening? Pop it from empty list. So whenever you are trying to pop something, make sure we don't have we have an element, don't have an empty list. So you see, I have given you an opening bracket, closing bracket. So it will come here. The character is closing. It will try to pop an element, but the stack is empty. I did not even push any value. So this is one thing. So that's why we have added one more condition. So the condition is, since they will not give us top here and we will not be able to figure it out. So what we can do is length of S. So length of stack. If length of stack is not equal to 0, okay, and if you pop an element, it should be equal to opening. It should not be. Length of stack equal to 0. The length should not be equal to 0. Or we have to keep, or if you pop an element, it should not be equal to opening, then it is false. If it is length is not equal to 0 and if you are popping the element and if the element that you are having is equal to the corresponding opening bracket, then everything is good. So we cannot do anything here. We'll move forward with the next one. So here I have copied it. I'll paste it here. I'll change it out for everything. That's one condition that you have seen. So opening square and open curly, right? Let's run it. Now let's run it. Now for that test case, it will be fine, but there will be other instances where it will fail. You see, for this test case, this is fine. Now let me show you one more instance. Okay. Now what if I go with something like this? Is this a valid one? No, it's not valid. But if I run it, I'll get this one as valid. You see, test case will fail. Test case will fail. Test case will fail. Okay. It's taking a bit more time because of the internet connection, I see. Located at some other place for training. So, yeah. See here, it is giving us true, but the actual expected output is false. Now, why? Why? Because you have appended two opening parentheses into your stack. You have only popped one and matched it. Now your string has ended. You do not have any corresponding closing brackets for your opening brackets. Now, where are your opening brackets? They are inside your stack. So once you come out of it, if your stack is empty, means for all the closing, you got a corresponding opening. Then only you have to return true. Otherwise, you should not be returning true. Okay. So I can also write it in one single line. Okay. I can write return length of stack double equal to 0. Okay. If length of stack is equal to 0, then it's valid, return true. Otherwise, it will be false. So now let's run it. For the test case that we have written, it will be fine. And you can submit it. Okay, let's submit it. Done. Right. So you see, for all the test cases, we got it right. All submitted. 1 or 2 out of 1 or 2 passed, and we are getting in 0 millisecond runtime. This is the optimized one. Okay. That's it. This is about the code. About valid parenthesis. This is a very common question, very popular one as well. Okay. So this will be present in that blind 150 questions that you get. 43% acceptance rate because of these hidden test cases only. Because of these small conditions, people fail to imagine, fail to think about. Okay. Now, how can you develop that type of logic? Whenever you are given a question, before submitting it or even while thinking your logic, think about the test cases where it can go wrong. Okay. It's important for you to prove it's a valid string, and it's also important for you to prove it's not a valid string. So you need to think about the hidden test cases where your code can fail or what all you could include. Done. That's it. That's about this question. Any doubts in this? Any doubts in this? You have seen good visualization of it as well. So that will help you with the other questions as well. So that's the maximum I'm trying to do here. Okay. Any doubt in this question? Any doubt in this question? Understood this one? Can we move forward with the next one? Any doubt in this question? Right? Oh, we got SpongeBob. Done. That's it. That's about valid analysis. Let's talk about conversions. Okay, influx to postfix, etc. and all. Let's see, where did I keep that? Okay. Just a second to check out my document and all. Mhm. My internet speed is fine now. You guys are able to hear me now. Everything is fine, or still any issues? Yeah, Kushi, once check out the YouTube recording today, so you will understand it. If you still get any issues, then I'll explain it again. Now just give me a thumbs up if Everything is working, audible, no voice breaking, etc. and all. Give me a thumbs up. Everything is working. I'm audible, clear, or is it breaking? Is it breaking or everything is working? Done then. So maybe I'm unable to find the exact animation of my stack one. Okay. Let me try to check it out once. Just a second. I have to organize everything at some point, but definitely not today. I think this is it. Not this one. Mm, yeah, fine. So see here. Now see, let's talk about yeah, no PPT will be shared. Okay, so you have it here in YouTube. These are all very private content. Okay, you will not find any of the questions that I generally show or present anywhere on YouTube because yeah, this is one of a kind. We only do that in big universities and product-based companies, students. Just giving you an idea. That's it. So these presentations will not be shared, so don't even have to ask it. That. Now, this is a low-key version of my final presentation, but anyway, just go through it. You see, we have three types of expressions. First one, we have infix expression. Infix in the sense, let me take a small expression to just give you an idea about what we are working with. We have a plus b. This is a regular expression that we have. If you have the operator in between the operands we call it infix. If you place the operator after the operands, we call it postfix. Okay. If you have the operator before the operands, we call it prefix. You might ask, sir, what's the need for placing it? It's good only, na? You see, computers actually understand things differently. For them, in order to evaluate an expression and all, we need to convert an expression from fix to postfix and all. Things will be a lot easier for the machine. Okay, and we will be also doing a lot of this stuff, so you will understand. First question, why do we need to know this? Because it's important. Lot of questions, lot of calculations. System does lot of things by converting it from infix to postfix. That's why we are doing it. So given an expression, we need to first convert it from infix to postfix. And these are some of my rules. First thing, you need to know about operator precedence, which one is having most priority. Okay. And simply calling board mass. If you get an operand, you need to add it to the postfix expression. We call it vector as well. If you get a closing parenthesis, you need to pop all stack symbols, okay, and add them to the postfix expression until an opening parenthesis appears, okay. And you also need to remove that opening parenthesis. I hope you remember balancing parenthesis. When we are getting a closing, we are also removing the opening parenthesis after checking. So that's one thing. Now, when you get an opening parenthesis, add it into the stack. Simple, last question only. When you get an operator, you need to pop all stack symbols until a symbol of lower precedence appears or opening bracket appears, then you need to push the operator. Okay. If the input is completed, if you have taken out all the characters and did all the above things, you need to pop all remaining stack symbols and add it to the expression. And I know this might sound a bit weird, but anyway, once we get into the coding part, then we get back here, then you will understand. Okay, so just have a good look at it. Good look at these 5 points here, or if you want, you can note it down at somewhere. Okay, take a good look. I don't want to rush or hurry. I think most of you are very new to this concept, so yeah. Anyway, people will be shouting about attendance in exactly 5 minutes or so. Maybe we might have gotten our first shot. No, not yet then. Okay. There is no problem submission. I want you to check out those questions. You see, ultimately, what's the main motto of an assignment? The students have to complete the task. They will learn something to do on their own. They will come up with doubts. That's the result that we are expecting. If you have completed even very good enough, if you are coming up with doubts, that's what I want. If you have completed it, if you have doubts, if you have clarified them, if you don't have doubts, that's very good. So that's what we are expecting. We want you to go through and solve a question on your own. We want you to get back with us if you have any doubts. If you don't have any of these two things, then it's fine. So we cannot manually check 1,000+ assignments and all, and that's not even required. The main objective of an assignment is for you to do it. I'm assigning you to do it. That's it. So take a good look at it and have a screenshot if needed. Take a good look at it and take a screenshot if needed. Okay. Mostly internet is working fine. Working fine. We'll see. I don't know that. Please contact admins. I don't think there's an exam. You have to attend all 15 days. And one more thing, certificates are only a part. Ultimately, people will judge your knowledge. Okay. Right. So that's it. See here, we have a infix to postfix rules and all. You can see this paragraph. I'll come back to this one later. Now see, we have an infix vector. We need to convert it into its postfix form. First character that we are getting is an opening bracket. So what do we have to do when we get an opening bracket? What's the first character here? First character is opening. Cursor is present here. First character is opening. So what should we do if we get an opening bracket? What should we do if we get an opening bracket? You guys have to tell me. You have seen those equations, na? You have seen those points. What to do if there is an opening? What to do if there is an opening? What to do if there is an opening? Opening means? Opening means? Very good, very good. No, not pop, push. Okay. Very good, very good. Let's push it. That's it. We have pushed it. Okay. We have pushed it in the now the next character is an operand. Next character is an operand. What should we do if there is an operand? What should we do if there is an operand? What should we do if there is an operand? A, B, C, 1, 2, 3, 10, 20, 30. These are operands. Okay. What should we do if there is an operand? Yeah, you have the points. Huh? Check your screenshot, check your notes where you have written it. What should we do if there is an operand? operand means place it into your postfix vector. So if I'm getting an operand, I need to add it into my output. Okay, done. Now the next one is an operator. Operator means I need to pop every element in my stack until I come across an opening. Okay, or until the stack becomes empty, or until I come across a lower precedence operator. So I have to pop everything until I get an opening, or stack becomes empty, or until I get an lower precedence one. So do we have a lower precedence operator? Okay, no. I got opening straight away, so I popped everything. There's nothing to pop there. I have to push it. So the second step is pushing it. So plus push it into the stack. Now again we are getting B. B means operand. Operand means add it into your post sector. Minus. Pop everything until an operator of lower precedence come across, or until you get opening, or until it becomes empty. Now you check plus. What's the operator inside stack? Plus. Plus is having lower precedence than minus? No. Plus is having equal precedence than minus. Then you have to pop. Okay. If it is having equal or greater, you have to pop that element. If it is having less precedence, then you need to stop there. Okay. That's operator precedence. So yes, we have to pop it, and minus we have to push, because after that we have opening parenthesis only. Now you see I'm getting operand again. Operand is posted into vector. Now I'm getting close parenthesis. Now I need to pop all elements until I get opening, and I need to pop that opening as well. Okay. So what happens when we get closing? I need to pop all elements until I get opening, and I also need to pop that opening bracket as well. So what are all the elements that we are having until opening? We only have minus, so pop it, and closing and opening it anyway. And the next value, next character is asterisk. Now pop all stack characters until we get opening, or until it becomes empty. Okay, it's already empty, so there is nothing to pop. Okay. Now you are getting an operand. Operand means add it into postfix vector. Operator, pop all stack symbols until you get an opening bracket, or until it becomes empty, or until you get a operator of lower precedence. See, we have is asterisk. We have lower precedence. Asterisk is having lower precedence. No, it is having higher precedence. So that's it. We have to pop it. So pop asterisk. There is nothing to pop there, so we need to push minus. So that's it. Popped asterisk. There is nothing else to push. Sorry, nothing else to pop. So push it. Now open means push. Operand. Add it to postfix vector. Plus we have to pop all stack symbols until we get an opening, or until it becomes empty, or until we get any operand of lower precedence. So we got an opening, so pushed. Okay, popping is done, so pushed it. Operand, post it into postfix vector. Closing bracket. We need to pop all stack symbols until we get opening. So what are all stack symbols until we get opening? First we have pop, and we are getting closing, so remove that. We are getting opening, remove that opening as well. Okay. Opening is removed. Now check your input vector. Do we have anything? No. And the input. What happens if the input is completed? We need to post all into the postfix vector. We need to pop all stack symbols. We need to place it in the postfix vector, right? So minus we have, pop it, place it into postfix vector. That's it. That's all it is. Okay. Now again, let me show you these. Let me show you these 5 properties. Okay. Just have a good look at it one more time. We will do everything manually through hand. Then we will straight away go and code it. Okay. Operand, add it to postfix vector, or let me write them as points. You see, first point, pop all stack symbols Okay, until an opening parenthesis appears. Done. Or until it becomes empty. Okay, that's one thing when you're popping, right? Now, operators means pop all stack symbols. Let me close the chat box. You guys are always crazy about attendance, which I don't like. Attendance link will be posted. If you're only here for attendance, happily fill it, then leave. Okay. People are crazy about certificate but don't want any knowledge. Okay, that's how the generation is. Right. So, yes. And remove the opening parenthesis at the ending. Okay. Opening means add it into stack. Operator, this is very important. Pop all stack symbols until lower precedence appears or opening brackets appears or stack becomes empty. Okay. Because when you are popping, empty is a very important condition you need to check. Now, second point, then you need to push the operator. This is the first one. First one, this is the second one. Now end of the input, pop all stack symbols and add it to the expression. That's it. Okay. Clear? Clear? Okay with all these points? Done? Done? Now see this one. Okay. This will be interesting. Now see. So see here. Now this is the expression I have. Let me write a small stack here. Okay. Let me draw a small stack maybe. I'll take this to the right a bit. Yeah, I'll keep it here. Now let me have a good stack type drawing. Done. Okay. Perfect. Perfect. Done. Now see. What's the first character? That is A. So A is an operand. Operand means push it into stack. Pushed it. So current symbol A. Inside stack we don't have anything empty. So postfix string. Sorry, I have pushed it into the stack. Yeah. So what do you have to do? Operand means add it to postfix vector. So let's say this is our result. Result is equal to we got A. Done. So A is completed. Now the next one is asterisk. Now whenever you get an operator, pop all symbols until it becomes empty or until you come across opening or until okay you come across something of lower precedence. Okay, so that's what we have to do. Done. Just a second. Yeah, done. So we have anything to pop? No, we don't have anything. So popping is completed. That's the first step. Now, second step is we have to push it. So let's push it. So if we push it, this is going to be the first value. So see, current symbol is asterisk. Operator stack, we have pushed it. Postfix is still A. Done. Right. Now see the next one. Got this screen. Yeah. Now see the next one. Next one is opening. Opening means you have to push. That's it, pretty simple. You see, opening is pushed, and we have A in postfix. Next we have operand B. Operand means what do you have to do? Add it into your postfix vector. You see, operand. This is the stack that you can see here, and this is the postfix string. Pretty fine. Next you got an operator. Operator means we have two things. First one pop. Second one push. Now when should we pop? Okay, until we get an opening or until it becomes empty or until we get a lower precedence operator. You see, we got opening. Now, so popping is completed. One is done. Now we need to go through the second one, that is pushing. So push it. Which one we have to push? Plus. Now you see, plus is the operator. Asterisk, opening, plus. Asterisk, opening, plus. That's how everything, right? And AB is still our result. Now do the same. Operand, add it to postfix vector. Operator, Pop all symbols until a symbol of lower precedence comes across. You see, plus is having lower precedence than asterisk. So we got a symbol of lower precedence. So popping should be stopped. Now push the operator. Okay, you see, pop and push. We have to do both for an operator, right? So you can see it here. Asterisk we got, asterisk bracket plus asterisk ABC we are having, done. Now D we have, add it to postfix vector, done. Okay. Opening we have pop all stack symbols until you come across opening. Sorry, closing we have pop all stack symbols until you come across opening. So pop the first symbol, asterisk is completed. Pop the next symbol, plus. You got an opening? Yes. Pop it. Now we have removed these three. We'll not be having any brackets in our expression. So you can see here A, B, C, D, asterisk plus. You see, we got closing. So the only symbol left is asterisk, and the postfix vector you can see A, B, C, D, asterisk and plus. Right? Now what's the next symbol? Plus. Pop all stack symbols until you come across a lower precedence one. Asterisk is having higher precedence than plus. So we have to pop it. Okay, so first pop, then push. So pop it. So pop asterisk, asterisk we have popped. Okay, now do we have anything to pop there after popping asterisk? No. Then what should we do? We have to push. Which one? We have to push plus. You see, plus is also pushed. Done. Now operand we have, add it to postfix vector, right? So E we have now 12. End of our input, we don't have anything. When you get to end of the input, pop all stack symbols. You see, plus we had, we posted it, okay, into our postfix vector. And if you observe A, B, C, D, A, B, C, D, asterisk plus asterisk, asterisk plus asterisk, E plus, we are getting the exact same thing. Okay, you just need to remember these points. What are those? What are those? Let me delete this. I hope you have seen good visualization of it. You have to remember these points that I have drawn. Okay. If you still did not take any screenshot, please do take a screenshot of it. This is what you have to look forward. Okay. That's it. That's it. So now let's code it. Let's see if there is any infix to postfix conversion in stack. If there is, we'll do it here. Otherwise, it will be in Geeks for Geeks. Infix to postfix. Let's see if there is any conversion. No. So let's copy it. Paste it here. We'll go with practice. I spelled it wrong. So let's see infix to postfix. This is Geeks for Geeks. It's a very popular platform in India. After lead code, you can get into this practice. I've clicked on it. Let's see, we should be able to get this. Done. Maybe I don't want to create an account with this. Maybe we'll do the normal one only. Okay, I'll do it in code editor. Now this is the stack input. Let me cut it out. I'll paste it here. Yeah. Now see. First, let's take an empty stack. Stack equal to empty. Okay. I'll ask the user to enter the string of parenthesis or a string of expression, or expression we'll call it. Expression is equal to input. It's a string. So we'll ask the user to enter the expression. The user will enter the expression. Now for character in expression, if character is an opening bracket, okay, you see parenthesis is only used in expression, so we can happily go with that. If character is equal to opening, if character is an opening bracket, opening parenthesis, for expressions only parenthesis will be used. So we need to append it. So stack dot append of ch. We have to append it. Okay. If the character is equal to closing, then what do we have to do? We need to pop all stack symbols until we come across an opening, and we need to pop that one as well. So keep those two statements in mind. We need to pop all stack symbols until we come across an opening. So when you're popping, you first need to make sure it's not empty. While length of stack is not equal to 0, okay, and stack of -1, the topmost element, okay, is not equal to opening, not equal to open until cross an opening, okay, right? We need to pop everything and we need to add it into a postfix. Okay, so let me do something. So let me write it as our postfix. So if I'm getting a closure, I need to pop everything until it becomes 0, or we will obviously get it open before that only. Just writing it so that you will keep this in mind for every other solution that you will do with stack later on. Of minus element is not equal to opening, we need pop, and we need postfix is equal postfix plus, okay, stack dot pop. This will be appended, right? And remember one thing, we need to also pop that. So what are we doing? Popping opening bracket, okay, popping opening bracket. Done. Right, so one condition is down, second condition is down. Now let's go with third condition. LF, if the character is not opening, if the character is not closing, okay, character should be an operator, okay, and operator means it will be either plus, or it will be either minus, or it will be either asterisk, or it will be either, okay, power, you can say. You can come up with a lot of other things. So we'll take only 5. So what are the 5 operators? I'll take plus, minus, asterisk, division. Since we cannot write double asterisk, it will be evaluated as single asterisk only. So generally we separate the input expression with space, and that's how things work. Let's take it as one single character. I know this is XOR, but let's try to convert it as power only. Okay, that's how it will be. Plus, minus, asterisk, floor division, and float division and power. Let's call that XOR as power for now. Done. So elif the character is equal to asterisk, also you can write, or character in plus, minus, asterisk, etc. and all in this manner. Okay, if it is any of these symbols, then what we will do? Then we will simply add it into, we'll simply pop all stack symbols, then push it. So when should we pop? We have some conditions now. While length of stack is not equal to 0. This is the first thing. While length of stack is not equal to 0, and topmost value of stack is not equal to opening. Okay, topmost value of stack is not equal to opening. Okay, and the character that you're going to get is having higher precedence. If it's having lower precedence, that's okay. Okay, so until length becomes equal to 0, or until you come across an opening bracket, or what you have, we have we have the topmost element priority less than it. So let's take priority. Let's create a small function. df will call it priority. I'll take a character. Okay, I'll just give my simple priority. If character is equal to asterisk, or character is equal to division. Okay, if character is equal to plus, or character is equal to minus, okay, we'll decide the priority as 1 for it. Elif is asterisk or division, will decide the priority as 2 for it. Okay, Elif, the character is equal to power, we'll decide the priority as 3 for it. Okay, power has the most priority. That's it. So you see, we are getting priority as well. You all know plus and minus have equal priority. Asterisk and division has equal priority. Power has more priority than any of these two operators. Plus and minus have lower precedence than asterisk and division. So that's how we are writing it. While length of stack is not equal to 0, and we did not come across opening bracket. Okay, we did not come across opening bracket. I'll make it to host and co-host. Do not ask for attendance again. You see, yeah, and the priority of the element, topmost element, okay, is greater than the priority of this particular value. Okay, so priority of the stack of -1 is greater than or equal to priority of the character that I have. If they have priorities in this manner, then I need to pop it. Okay, I have to pop it. I have to add it into postfix expression. Postfix is equal to postfix plus stack dot pop. That's it. So we are popping it. We are adding it into our postfix expression. Done. Then there is one more thing as well. You need to push it back. You need to push that operator stack dot push. Sorry, append of ch. We need to push it back into the stack as well, right? So if it's opening, append it. If it's closing, pop everything until you come across an opening or until it becomes 0. Add it into postfix. Then you need to pop that opening. If it is a character, then until your length is not equal to 0, until you did not come across opening, and until the priority of the element inside the stack is greater than or equal to priority of the character that you have, pop it until you come across a low precedence. Pop it, add it to postfix, then append the character. Okay, that's it, done. Now else, if it is not an opening, if it is not a closing, if it's not a special character, it's an operand only. Operand means you have to add it in postfix vector only. Postfix is equal to postfix plus ch. That's it. 4 conditions are done. Now what about the 5th condition? Once I'm done with the input, once every character is completed, once I come out of it, if stack still has any symbols left in it, so while length of stack is not equal to 0, I need to pop all those elements. I need to add them into postfix vector. Postfix is equal to postfix plus stack dot pop. Okay, if stack, after going through all the characters in the input, after coming out, if stack is still not empty, I need to add all those characters into the stack. That's it. Once I do that, everything will be done. So this is going to be the postfix vector, we call it generally. So let's go with postfix. Right, so that's it. These are the 5 conditions translated into code. Okay, pretty easy. Once you read those 5 statements, once you check these translation, you will understand them properly. Let's check it out. Let's see how things work. Let's take out these 2 examples that we already have. We'll take a plus b minus c into d minus of e plus f. Let's run this code. We'll take a plus b minus c, okay, into of what do we have? Into d, what else? Minus of e plus f, okay. I hope it's right. Yes. So let's run it. AB plus C minus D asterisk EF plus minus. Let's see if that is correct or not. AB plus C minus C of E plus minus. That's it. It's correct. Okay. So what happened? Yes, you can post anything in the chat box if you want. If it's breaking also, I'll be happy to explain it again. That's the first condition. Now let's see that for the second question as well. This is fine. So we have, we will cover A asterisk B plus C. Let me copy this. It will have spaces in it. We'll remove that. Okay. It will have spaces in it. Done. Okay. Okay, so I got everything here without the input part. Yeah, maybe we'll type it out only. Yeah, where is it? Yeah, I'll type it out. We have, let's take it in capitals, A asterisk, B plus C asterisk D plus E. Okay. You see A, B, C, D asterisk plus asterisk E plus. That's the result. A, B, C, D asterisk plus asterisk E plus. That's it. Okay. Given a infix vector, this is how you can convert it into postfix form. Okay. So pushing the operator here. Okay. These are the 5 steps. You can keep them side by side. You will be getting an idea about it. Let me try to do that. Okay. Let's make this as full screen. Yeah, see this. Okay. Let's try to zoom in even more. Done. Check it out. This is the exact same translation part for it. Okay. Opening means push it. Closing means pop everything until opening comes across. Operator means pop all symbols until opening comes across, or until it becomes zero, or until lower precedence comes across. Now, how did I set precedence? Simple. I've created a function called priority. If I'm giving plus or minus, it will give me 1. If I'm giving asterisk or division, it will give me 2. If I'm giving power, it will give me 3. So that's how I'm checking it. Okay. That's how I'm checking it. This is how we are going through it. Done. That's it. This is infix to postfix form. Please take a screenshot of it if you want. Take a screenshot of it. Take a screenshot of it. Okay. That's about conversion of infix to postfix form. Okay. Any doubt? Any doubt in this? Do you want me to explain anything again? I'll go to meeting group chat again. Any doubt? Do you want me to explain anything again? Any doubt? Yeah, you can post a message in the chat box. You all have access. Okay, it's meeting group chat. It's not being converted to meeting group chat. But sorry, I got disconnected. Sorry, I got disconnected. Yeah, we have gone through it. I hope you guys have seen it. Did it break anywhere or everything is fine? I'm making it a group meeting group
Sir, I
chat,
think
but
there
it's
is
still
some
not
network
working.
issue.
Okay. So what was the last thing? Like, have you seen the entire solution? That was covered, right? I think I've completed it 1-2 minutes back only.
Actually, screen
You
got
guys
dropped, sir.
have okay. You guys have seen the entire solution, or do you want me to code it again? You have not seen any part of it.
Last 1 or 2 minutes, sir.
Okay, okay. Yeah, I was just comparing both of them side by side. This is the exact same translation of it, so that's what we have. Where is this? It's not coming up now. Yeah, this is the code that we have. I was just keeping them side by side. Yeah, not even. Yes, anyway, I'll just keep it this side now. This is the exact same translation of the 5 points that we have discussed. So have you seen or have you listened to the entire coding of anything there? Tell me the line number from where it was not audible or so. I'll be happy to repeat it again. Okay. I hope before that connection lost, 1 2 minutes before itself, I have completed it. Just going to so everything is fine. Any doubt till this point? Let me open out. Yeah, open it. At this point, do you want me to explain anything again? Any doubt till this point? Hello, I'm audible. Everything is working. Hello. You guys are always crazy about attendance.
Yes, sir, you are audible.
Yeah. So that's it. That's the last question for today. Then, if you have any doubts, please check out the recording again in YouTube and get back to me tomorrow. Okay. That's it. We have 2 more minutes. I think we are good to close. So, post if you have any doubts. I'll be here for 1 more minute. The exact 5 points that we have discussed, the same translation of it. It's not nothing new here. Okay. Check it out. I hope you have taken a screenshot of it. And line number 61. Okay. You see, we need to keep popping the stack symbols until it becomes empty or until we come across opening or until we come across any operator of less precedence. Okay, so we are checking the priority now. I've written a simple function for it. If it is plus minus, priority is 1. If it is asterisk or division, priority is higher than plus or minus, so 2. If it is power, we are taking XOR as power, its priority is 3. So same line translation you can see here. If it is an operator, pop all stack symbols until low precedence appears or until, okay, opening parenthesis appears or until stack becomes empty. That's what we have. Okay, popping it, adding it to postfix. Now, once you pop the stack symbols, whatever character that you have, you need to push it. So that's what we are doing. It's the second point. So I've written 2 points, then push the operator that you're holding. Okay, that's it. That's about it. Exact simple. Done. Done. Anything else? Anything else? Anything else? Fine. Then. That's it. That's it. I'll see you tomorrow. Bye bye.
Okay, thank you, students. Guys, I don't know what's wrong with you. You're joining only for the sake of attendance. I also observed that couple of times attendance. You know that at 8:30 attendance is going shared. After that, after 5 10 minutes again, attendance is going rolled out. Still, you will message the same things. And if sir asks for the confirmation that audible or not, or if sir is not audible, at that time you will not take care. From tomorrow onwards, these things will be not accepted, guys. Okay. So if you want attendance, be there in the session attentively. Just don't join for the sake of attendance, right? Sir asked many times that audible or not, but you not try to answer as well. But whenever it's part of attendance, you will start pinging.